Hello, welcome to Lesson 8 of our FLL series on the fundamentals of LEGO robotics. In this lesson, we'll focus on two key strategies that can make or break your robot runs: mission planning and modularization. Mission planning is about deciding which missions to attempt, in what order, and how to approach them. Modularization is about designing your robot with interchangeable parts so it can adapt quickly to different tasks. Together, these skills help teams save time, reduce errors, and score more points during a match. To follow along today, you'll need the LEGO Spike Prime Kit, a computer or tablet with the Spike app, and a paper and pencil for brainstorming and planning strategies. This is optional, but if you'd like to test these attachments in a real setting, get the FLL game field and mission models. First, let's talk about mission grouping. One of the most important parts of FLL strategy is deciding how to group missions or tasks the robot has to complete. Grouping helps save time and makes your runs more efficient. There are three main types of grouping. First, location-based grouping. Missions that are close together are grouped to minimize travel time here. Example of this is when you complete two missions in the northwest corner of the field before moving away. Second is task-based. Missions that require similar robot actions can be grouped together here. An example of this is grouping missions that involve pushing objects into target zones. Lastly, attachment-based grouping. Missions are grouped so one attachment can handle multiple tasks. An example of this is a single arm attachment that can both grab and push. Other key considerations when planning missions are point value, so you want to focus on the high point missions, but balance them with difficulty. Also, risk versus reward missions. You want to first start off with the easier, more reliable missions to secure your points before moving on to the riskier missions. Lastly, time management. Use timers during practice to measure mission runs, including how long it takes to swap your attachments. The next topic is runs. A run is a continuous sequence of missions your robot completes without returning to home. Planning runs is a critical part of strategy. You want to balance time and completion. Plan each run so you can finish within the 2.5 minute time limit. And also, you can use the multiple run strategy, which means you can break missions into separate runs, like doing easy high point missions first and saving the harder ones for later runs. The next topic is attachment design theory. Since robots often only use 1 to 2 motors for attachments, it's important to design them to be efficient and effective. Some design principles you can apply when doing this are multifunctionality, so one attachment should be able to do more than one mission when possible. Second, ease of use. Attachments should be able to attach, detach, and operate easily. Third, durability. They should hold up through repeated practice and competition use. Lastly, reliability. Attachments should perform consistently without failure. Next, let's move on to modularity. What is modularity? A module is a standardized part or unit that can be swapped in and out as needed. In robotics, modularity means building attachments like modules so they can easily change between missions. Modularity can help with flexibility so you can quickly adapt to different missions without rebuilding. Efficiency, meaning you can save valuable times during runs with fast swaps. Examples of modularity in robotics could be modular arms or tools that connect to motor ends, and quick release mechanisms for rapid changes. Next, let's talk about simplicity when you're working on your robot design. A principle we apply is the KISS rule, which means keep it simple, students. Simple designs are easier to build, test, and repair, and they are way less likely to fail under competition pressure. An example of this is a basic gripper with fewer moving parts, and this is often more reliable than a complex, delicate mechanism. Benefits of simplicity include faster design and build time and fewer points of failure. Now, let's apply what you've learned today in an activity. You can now design your own attachment, and we want you to build this to complete one of these sample missions. The first option is to push or pull a lever, which is in the shipwreck mission. The second is push down on a button, which is in the shark mission. And lastly, hang an object from one area to another, as seen in the scuba diver mission. As you work on your attachments, don't forget these design principles. The KISS principle, which is keep it simple students, modularity, and multifunctionality. Here's the sample attachment that I designed for the shark mission. To first move the shark out of the cave, I built this lift arm. And this lift arm will dislodge the shark from the cave and put it on the side. Once it's on the side, you can take your hand and bring it back to your home area, where you'll put it on this gray shaft that I built. And then once you have the shark sitting upside down on that, you can use the lift arm, which is already attached to the robot, to push the shark, which is in the shaft, to the target zone and score the remaining 10 points. In this lesson, we explored mission planning and modularization. Here are some key takeaways. Mission planning involves grouping tasks, managing time, and balancing risk and reward. Modularization makes robots more flexible and efficient by allowing attachments to be swapped quickly. Together, these strategies help FLL teams maximize points while keeping designs reliable and simple. Thank you for watching our FLL series. We hope you learned something new in this video today.